这涉及到两个问题，刚刚律师说的，第一个问题是基本上以前我们在传统社会中，信任是一种人际关系的大幕，就是你要慢慢建立一些信任关系。可在网络社会里头，我们的信任关系就会变成是一个非常困难，而且很难获得的权利。而这个权利有时候必须要通过技术的手段来实现。那我觉得两边他们这群同志们做的事情很重要的一部分是，我们如何用技术的方法让你的选择可以变成这个权利的保障。这个事情其实越来越关键，越来越重要。好，我们第二位主要的那个OK， 马克纳达尔已经在现场。那我们介绍一下第二个 panel 的 list 的我们第二个讲者是马克纳达尔，他目前他曾经是一个数学家，那后来成为一个程序员，现在他经营的一个开源公司叫 PHRA。那 PHRA 是一个开源的创新实验室。专注于将去中心化的网络在基础设施应用安全方面的尝试，还有另外一个是，他也尝试了 GUM。那 Mark 曾经游历了30个国家，他可以领略到多元文化基金对他的学习、分享及他为所有人创造免费的开源技术的热情。那么现在他希望能够为所有人提供一个真正去中心化的网络。那他的讲题非常的明确，也非常的重要，叫做如何建立与架构一个分布式网络。我们现在欢迎那个马克纳达尔。
Can you just say something, and we can see if the volume sound is good?
Hello, I'm Mark Nadal.
Yes. Go ahead, please.
Thank you so much for having me on the conference. I'm excited to talk to you about the decentralized web and how to scale it up to hundreds of millions of people. So we're going to start off by first discussing what decentralization itself is. And in order to understand decentralization, we have to know what being centralized is. So centralization represents any bottleneck or point in a system where if a failure occurs, all of the other devices, all of the other computers, and potentially all of the other humans suffer from this one thing not working. So to then go on and say, what does decentralization mean? Really, it's about saying we want to create not only an internet or a system that is resistant to failure, has less failure, is immune to failure, is resilient to failure, but that this is a system that is also better for humans. Because when we create more robust and resilient systems, through decentralization, humans are able to survive better. Humans are able to have less negative impact. If you go to Google, and there's billions of people using Google, and Google's servers are down, Facebook or Amazon, then you can't get your work done. You can't get your job done. You can't search the web because, for instance, very recently with Apple's new Big Sur operating system, people try to open up an application on their computer to write code. And because Apple's server that checks whether the application is connected and has the right certificate for the Apple Store was down, people could not use their offline applications because Apple's server was down. That's crazy to think that opening up a local application on your computer was not allowed because Apple's server was disconnected. That one failure produced failures for probably billions of people. I don't know if billions of people are already using the new operating system, but that represents how centralization can cause a lot of problems for people. Decentralization is a way to stop that. So if we have decentralization, we may want to figure out what are the algorithms we can use to create and to scale that. There's a lot of different approaches. Some of the most famous approaches have been blockchains, or using what is called append-only immutable logs, content addressing, or directed acyclic graphs called DAGs. A lot of those algorithms, I argue, do not scale well, because for each additional piece of information you have to add, you have to understand the entire historical context and either have a snapshot of it or have access to verify the new update against the entire history. And so as you add each new record, there's no going back. You accumulate a lot of baggage that you may not need anymore, but you have to use it in order to verify each new operation. So don't get me wrong, blockchains are wonderful. Immutability is fantastic, but they do not scale as well to larger and larger population sizes. So there's this wonderful algorithm called a CRDT, a convergent replicated data type is the mathematical name or phrase for this thing. And it allows you to do both mutable and immutable data. The immutable data has the same scaling properties as the other systems, but being able to do mutable data, where you're able to change the data, allows us to scale very nicely. And here's how the algorithm works. You have Alice and Bob. Alice might ask a question like, do you like cake? Bob does not interpret that statement literally. Bob understands that there's a type of deterministic change in the pronouns from I to you, or you to I, such that the question is interpreted relative to the context of the speaker, even though Bob received or heard the actual phrase, do you like cake? Bob interprets it as, do I like cake? So when Bob replies and says, yes, I do, the same thing reverses. Alice has an understanding that the phrases you and I do not correspond to their actual statements. They correspond to a shared model of reality that both Alice and Bob are trying to converge upon. Alice takes I, that Bob said, and converges upon, that means Bob. And Bob takes I, relative to him, and understands that I converges to himself. Bob likes cake. So this type of determinism, where you automatically take any ambiguous statement and interpret it relative or opposite of what the receiver has actually said, is a type of convergence that gives us a shared model of reality that we both understand and is correct. So convergent replicated data types, also known as conflict-free replicated data types, there's a lot of research on them online. So if you want to learn more about them, look them up. They give you a type of deterministic consensus without any operational coordination. And that's because every single machine is running the same algorithm underneath. Both machines wind up receiving the data and interpreting the data relative to some deterministic rules. An example is, in our system, we use alphabetical sorting in order to make sure that regardless of how the data was sent, it might not have been in an alphabetical ordering. But if every single computer winds up sorting the data alphabetically, it doesn't matter how the data was sent. Every single machine will process the data in the same way because it is alphabetically sorted, regardless of how the data was received. So those are a couple of examples of how these convergent replicated data types or commutative replicated data types work. I'm going to end with the explanation by explaining what convergence and commutative means in mathematics. Commutative is just saying that A plus B equals C is the same thing as B plus A equals C. The order of the operation does not matter. You get the same result. So in mathematics, addition is commutative. Subtraction is not. 5 minus 3 is 2, but 3 minus 5 is -2. The order of the operation matters. And order of operation matters in blockchain. It matters in directed graphs. The order of an operation matters in immutable systems. However, I should say append-only logs. However, the order of operation does not matter in commutative replicated data types. In CRDTs, the order does not matter in addition. The order does not matter if we say Bob, you, or I. We all produce the same result. These algorithms work incredibly well. The CRDT that we use in our system, which I'll give you an example of in just a moment, called GUN, has been able to scale up to 50,000 users per second. We've seen about 30 million people per month using our technology. That's incredible. I've not seen any other system other than BitTorrent from years and years ago have that type of operational scaling for the decentralized web. So it turns out that math and algorithms are extraordinarily important. So we just crossed 200 million downloads in 2020. This year, in 2019, we did 22 million downloads. And I thought, wow, that's a lot. So when we passed 100 million downloads in July of this year, I was so ecstatic, so happy, so grateful, because that was a new boundary we had never seen before. Yet just 4 or 5 months later, we've already doubled that again, thanks to the incredible projects, websites, and teams in our community, including people like Yisi from Maskbook creating encrypted end-to-end communications on top of Twitter and Facebook and other applications. The type of things that you can do with this type of technology is really incredible. And so it's exciting to see the growth of the decentralized web being powered and scaling with CRDTs. The type of CRDT that I work on is called GUN. You can check GUN out more by going to gun.eco. It is an open source and free decentralized database that has a cybersecurity protocol built into it, so that way your data is also safe. And now for the next portion of the talk, I'm going to be jumping in and giving some demos of how easy it is to create these decentralized applications. Okay, so coming over here, the first one I want to show you is a Hello World app. We have 2 browsers. This could be 2 devices, and I could just type Hello World, and the information syncs between both of them. I know the screen is a little bit small, but I'm going to come over to the code for this. So you might think to do decentralized applications, there's going to be a lot of code, or that you might have to download and install some special software. It's been very, very important for me to create a tool that is very easy to get started. So that decentralized application, that is just a copy and paste tool, is only 17 lines of code, and it's right here. You have some basic HTML. Yes, I'm using jQuery. You could use React or Vue or Svelte or all these other JavaScript front-end tools. You can use whatever UI framework that you want, and then you include Gun. There is a public CDN that you can load Gun from, but because I have installed Gun locally on my computer, I can just reference Gun from my computer directly. So the couple of lines, 1, 2, 3, 4, 5, that it takes to create this very simple application is as follows. First, you want to start the database called Gun. And when you start the database, you have to connect to other peers in the network. Those other peers, the first one is my computer itself. So my computer, if I have Gun installed locally, winds up acting as a Gun peer. You might think of this as being a type of Bitcoin node. There is no going on because we are using the CRDT algorithms. So Gun is very lightweight and can scale easily. It's okay to run on your computer. It even will run on a phone. And so the first peer that we're connecting to is our machine itself. This means we can work truly offline. Another peer that we might connect to is another peer out on the internet. This could be the laptop of your friend, if you know their IP address. However, because the internet has firewalls, oftentimes we cannot talk to other computers directly without using a coordinating peer. A coordinating peer, or a relay peer, as we call it, is not centralized. Any other Gun peer is a relay peer, including other browsers, if you connect to them. In fact, there's a funny story about how that caused a lot of web traffic for Maskbook, for masks.io, because the browsers were relaying all the data back up to multiple other relay peers that they had, increasing their traffic by a lot of data. But that's a separate story for some other time. So one of these relay peers, because the internet has these firewalls, we have to connect to a peer, and that peer will then automatically connect us to other peers, including any other browser, like the two browsers that I showed here. Those two browsers will automatically connect to each other over WebRTC, which is a browser-to-browser technology, or other fallbacks by using WebSockets to connect the two browsers via the relay peer. You can think of relay peers as acting as your Wi-Fi router. The Wi-Fi router just takes information and it passes it along in the correct direction. You do not need one. If you have one of these, then it's centralized. But if you have many of them, it is decentralized. Any one can fail, and the rest of the system will still work. So that's the first line of getting started, is connecting into the decentralized network. The next is our UI code. Again, you could use React or Vue or Svelte or any of these other tools out there. But in this case, it's just jQuery, and it's saying listen to any change to the text area when somebody types a new message. And that gets triggered like that when I type. This then tells, hey, look up in the database, a key value lookup, the test record. then traverse into the test record and get the paste property, because we're trying to build a simple copy and paste tool that lets us easily copy information across our different devices, just for a very simple hello world demo. Now, once we have gone into the record that we want with gun, we then say, here's the data that we want to put on that record inside of this database. And that just happens to be whatever was typed, the value of the text area. And once that put gets called, this next line on all other computers that are connected to that decentralized application automatically get called. They say, hey, I want to listen onto any data change that corresponds to paste on test. And then we take the data that we have received that's been synchronized over the decentralized network and put it back into the text area. It's as simple as that to create a decentralized application. But I want to show you something a little bit more fun. So here's the next basic application. I'm going to come in here and create a user. Sign up over here. I'm going to log into that user. And now I have a to-do list. As soon as I add an item to our to-do list, it automatically synchronizes to the other logged in user under that same account. This is really neat because this system, let me refresh. If I try to log in with the wrong password, it doesn't work. Or if I log in with a different user, I get a different user list. So if I come over here, I have a multi-user collaborative to-do list. You might think, oh, wow, we have now added users into this system. This is going to be hard and complicated to create a decentralized application. Well, no, it's only 52 lines of code. And it would probably be smaller if you were using a UI library. There's no UI library here. We have some basic HTML, the sign-in form to create and log in, the form to take the input, the to-do item, and then the list that we want to show. And we've added something new here. Not only were we using jQuery or whatever UI framework you want, React or Angular, we've included Gun, but we also have included this thing called C. C stands for Security Encryption Authorization. And C contains the code for us to create cryptographically verified and end-to-end encrypted users, all in just a few lines of code. So I'll go over that now. We initialize the database as we did before, and we call this thing called gun.user. This gives us a user that we can work with. When somebody clicks on the sign up form, we just say we want to create a new user, and we pass it the username and password. This might be a little confusing for a lot of people used to blockchain and other systems, which is usernames and passwords are insecure. You are correct. They are insecure. However, the very cool thing about this technology is it creates a public-private key pair for you underneath. And that is cryptographically safe and secure. And it then tries to associate it separately with a normal username and password combination. And the way we keep this secure is we take the password. I actually have a slide on this. We take the password and we use 3 cryptographic methods to make sure it's protected. There's this algorithm called PBKDF2 that takes a normal password and combines it with the salt, and it produces a proof of work. It takes some amount of time and computer resources to generate this key. And that is now used as the actual kind of password for encrypting using AES our private and public key pair. So PBKDF2 takes any normal insecure password and adds proof of work to it to create a cryptographically safe system for protecting and logging into our key pair. The reason why it's safe is because if a hacker were to come along and try to brute force attack our system by using guesses, it would wind up taking them about 50 years to 100 years to guess our password, because the proof of work adds in additional time for each guess. We have created a cartoon video explainer that shows how these cryptographic algorithms work. And you can check them out by going to our documentation at gun.eco/docs/all capital CSEA. I'm going to jump back to the applications because there's one last one I want to showcase. To quickly end the review on this application, there's then also the login function, which we call user.auth, and we pass it if we want to log into our user rather than creating our user. We pass in our username and our password, and that will attempt to log into our decentralized, cryptographically secure user account. So upon getting logged in, we want to hide our login form, and we want to get what is being said by the user, the to-do list. And we simply call a .map function, which works like a for each. You can transform the data in the map function, but in this case, we want to keep the data the same as before. And we then pass it to a UI function to print and display onto the screen. The last piece here is when a user submits a to-do item, we want to make sure that we find the user. We then access the said property or the to-do property on that database, and we set what they have said. A set is like a mathematical set. It works like a table. We're trying to say, here's this item, and we want to add this item into the table or the set of things on this. So in just 53 lines of code, you can create cryptographically secure, multi-user, collaborative to-do applications. The very last demo that I want to show, and I don't actually, let me try, is you can also create a type of TikTok clone with this. I don't know if I have a finder. Actually, I was trying to look buck. Here we go. So I'm going to take a video, a big buck bunny, and I'm going to drop it into, and this video just synchronized across those tabs. So yes, you can even drag and drop videos and images and photos and songs into the database, and it will synchronize across applications. So just as a quick example of what that looks like, you might think it's a lot of code. No, it is only 34 lines of code. You can review this on your own on our website and our GitHub repo. So now let's go back to the presentation and end things up, wrap things up. So we already reviewed the cryptographic algorithms, of how this works. We've done a demo of it, and we've explained the algorithms that make this technology work. So the last thing I want to end with is the future of where we're going to go. Now that we've created a decentralized network that scales to tens of millions of users, we now need to focus not on the technology, but on the psychology or the economics of these systems. And so our plan is to create a series of video games that get people playing together on a new type of social network where that video game itself is decentralized. So by using, I see that there's a question, but Zoom is not letting me pull it up, and we might have to wait until the panel. So if you are interested in helping us build the future of decentralized networks and gamifying it, please come and join our community. Thanks. I'm Mark Nadal. I'm the author and creator of the Gun Database, and we are ERA as a company trying to create a better decentralized future for everyone. Thanks.